Okay, welcome back. Now we've got a situation where we have a triangle and these are the three sides, the measurements of the three sides of the triangle. And so now we're going to use law of cosines to find one of the three angles. So in this case, what you're going to want to do is you're going to want to find the largest angle. Okay? It doesn't really matter, but you want to, I would just find the largest angle, because if it's an obtuse angle, then you can use some of the things that we learned before, yada, yada, yada. Okay, so, but typically it doesn't really matter, but it is a good strategy to just work with the largest angle and then go from there. Because if the largest angle is an acute angle, then you know all the rest of the angles have to be acute. So we know that the angle is going to be across from the largest side, the longest side, which is C. So let's find angle C. So we're going to set this up by setting up our equation, the law of cosines, involving C. So that would be C squared equals A squared plus B squared minus 2AB cosine C. Okay? And so now what we're going to do is we're going to plug and chunk everything that we know. So C is 165, so it's going to be 165 squared equals 106 squared plus 135 squared minus 2 times 106 times 135 times cosine C. So now what I'm going to do is I'm going to solve for cosine C. So what I'm going to do is I'm going to subtract off these two. So it's going to be 165, so here. So I'm going to get 165 squared minus 106 squared minus 135 squared equals negative 2 times 106 times 135 times cosine C. Well, now I'm going to isolate cosine C, so I'm going to divide by this here. So if I divide everything by that, right, so I'm going to divide this whole thing by negative 2 times 106 times 135, okay? And so what happens is I get cosine C is equal to this thing here. Now, if I take the inverse cosine of both sides, then guess what? C is going to equal inverse cosine of that whole thing. So I'm going to take that whole thing, right? And stick it in here. And so if I stick that in my calculator, again, be careful if you're going to do everything in your calculator, okay? But if you put this in your calculator and then if you calculate this and then take the inverse cosine of whatever this answer turns out to be, then what you're going to get for angle C is going to be approximately 85.5 degrees, okay? So you'll get approximately 85.5 degrees. All right, so there we go. There's the first one. Okay, now, at this point here, we can use the law of sines. Because now that we've got this angle, this side, or this side, and we've got these two sides, now we can use the law of cosines, or excuse me, the law of sines to get the next one. So, or we can use the law of cosines again, okay, and go through the same thing. Let's use the law of sines. Okay? So now, I'm going to solve for A. So, not cosine, sine A over A is equal to, not cosine, sine C over C. And so now I'm just going to plug in my values. So it's going to be sine A divided by 106 is equal to sine of 85.5 degrees divided by 165. And so now I'm going to multiply both sides by 106. And so I get sine A is equal to 106 times sine of 85.5 degrees divided by 165. And so of course, if I take the inverse sine of both sides, I get A is equal to sine inverse of that whole thing. And so again, I'm just going to take this and stick it in there. And then what do I get? A is approximately equal to, what do I get? 39.8 degrees. So 39.8 degrees. So that's the second one. Now I'm pretty much done because I don't have to use any of these formulas anymore. So A is approximately 39.8 degrees, and now all I have to do is use the fact that all three interior angles must add up to 180. So B will be approximately equal to 180 degrees minus what? 85.5 degrees minus 39.8 degrees. So that means B will be approximately equal to what? .125, so this is 125.3. Hold on. Yeah, so 125.3, so that's going to be .54.7. And there we go. We solved the triangle. Have a great day.